We are looking at the worksheet for section 20.2. This worksheet is going to help you practice using the aldo and keto prefixes and the triose, tetros, pentos, hexose suffixes. And on this worksheet, you're being asked to draw an example. There may be more than one correct example of each of these different types of monosaccharides. So here's how I approach a problem like this. I start with the number of carbons. So I start at the end of the molecule's name. This says triose, which tells me that it is 3 carbons, tri for 3. The next thing that I do is go to the prefix, aldo. The aldo tells me that my carbon-oxygen double bond is on carbon number 1. And because this is a monosaccharide, every carbon either has to have a carbon-oxygen double bond or it has to have an OH. So that's like the skeleton of the molecule. And then I'm going to go back through and add hydrogens to all of my carbons. And I'm going to add enough hydrogens to each carbon so that each carbon has a total of 4 bonds. And that's it. Now, in terms of, is there more than one correct example? Well, yeah, we could have drawn the OH in either the left side or the right side of the molecule. So I just drew 2. 2 different versions of the aldo triose. So let's move on to the next one. We're going to start with how many carbons do we need? Hexose means that this is going to be a 6 carbon sugar. 1, 2, 3, 4, 5, 6. Aldo means that the carbon-oxygen double bond is on carbon number 1. And then for all the rest of the carbons in the molecule, I'm going to put an OH. And I could either put it on the left side or the right side. It's going to be totally up to me. Notice that it's not going to be like this. So when we're writing OH, we don't always write OH left to right. That's something that is often confused with intro 100 level students. The oxygen is always written directly adjacent to the carbon like this. So whether we're going from left to right, the connection is going to be between the carbon and the oxygen. And once I get an OH on every single carbon, then I'm going to go back and I'm going to add as many hydrogens as I need to make sure that each carbon has 4 bonds. Let's look at another one. Hexose, again, that means that I'm going to have 6 carbons in my chain. This is a keto, which means my carbon-oxygen double bond is on carbon number 2. Every other carbon is going to get an OH. Maybe we put some over on the left. And then we go back and add hydrogens to every carbon atom to make sure that every carbon atom has 4 total bonds. Notice that carbon number 2 doesn't need to have any hydrogens put on it because it has 4 bonds already. We've got 3 more to practice. We have a triose, so that's going to be 3 carbons. Keto, meaning that the carbon-oxygen double bond is on carbon number 2. Our other carbons will get an OH group. Add hydrogen so that every carbon has a total of 4 bonds. Next one, we have a pentose. That's a 5 carbon chain. Aldo means that the carbon-oxygen double bond is on carbon number 1. I don't know why, draw my carbon-oxygen double bond when it's on carbon number 1. I always draw it leaning to the right-hand side, but you don't have to draw it that way. It could also lean to the left. So you could see it either leaning to the left or leaning to the right. Now we need to put OHs on the rest of our carbons. And then we need to go back and add hydrogens to each carbon to make sure that each carbon has 4 bonds. And our last option, we have a tetros. Tetros means 4 carbons. Keto means carbon-oxygen double bond on carbon number 2. Everybody else gets an OH. Go back and add as many hydrogens as you need. so that all your carbons have 4 bonds.